my name is Chloé Vaniet, and I'm working for a company called Usefull Progress. And the company has developed a web-based software enabling users to view, explore, and share 3D data. And this is a non-invasive and non-destructive tool that offers a new approach for research, investigation, and also archive. And this is a software we use with Alain Froment to make all the measures of the maories heads. So the company is a French company. The development and research department is based in Paris, is in the University of Medicine, Paris-Descartes. And the production is in Montreal. And in order to spread around the world the solution, the chairman of the company created an American company called Visura 3D. And this company is in charge of the business development. So you can see here some of our partners and customers. And as you can see, we're already working with a lot of museums, such as the Musée du Quai Branly, the Musée Guimet, the Louvre, and also the British Museum in London and the Film Museum in Chicago, and of course, the Muséum d'Histoire Naturelle. So, as I said, we're working with images coming from medical devices, such as MRI, CT scan, or ultrasound. And we're mostly working with CT scan images. The software was first developed for the medical field, as you can imagine, but then as now we can pass through a scanner almost everything we want, like such for instance, fruits or engine or everything. And we also realize that a lot of other fields, such as industry and museum, also want to be able to see the object in 3D and see through all this object. And so from a CT scan, we can get this kind of images, like we can work on 2D images, but also on 3D, and playing with colors and transparency, we can make the object like look different, just show the bones or put the skin on it, remove it. So, as I said, the company is offering mainly three things. The first one is the scanning process. We're working with a lot of hospitals in Paris and also in the US. But we're not just taking the object and pass them through a scanner. We're also working with the technician at the hospital to be able to improve all the process of the scanning and all the settings to be able to get the best images. Then we offer the possibility to all the users to be able to explore and view in 3D all the object. Most of the time now in the hospital, there are only the radiologists that can see the object in 3D. The other are just using the 2D view. So we wanted to make everyone be able to view everything in 3D. And the last one, and also an important one, is to be able to share your work with everyone you want. So once you work on an object, you make a lot of research on it, you want to share it with your colleague and also with other museums, for example. And so all the advantages are written there. And the most important one is that it's a non-invasive and non-destructive way of making research, especially when you have delicate subject. And also, it's another way to get like a storage things. So once you have your object passed through a scanner, you have it forever. You don't need to have like probably it anymore in your collection. You just have it on the servers. So I'm gonna try to briefly explain the workflow from the CT scan to the online 3D viewer. So first, the CT scan. So in the 1970s, with the development of the computers, Lord Hounsfield created the first CT scan, combining radiology and computing. And from a CT scan, what you get is the slices of the body, usually. And if you put all these slices together, like making a stack of slices, you get a volume. And instead of considering just the pixel of the slices, you consider the small volume, which is called a voxel. And each voxel has a value corresponding to the absorption of the X-ray. And this value has been seen as an image of the density of the object. So then you got this curve, yeah, right there, which is the number of voxels regarding the density. And playing with this curve, you can decide to show or hide different parts, like the bone, the fat, the muscles. And combining this curve, you can get this kind of images. So, for example, you can decide to show only the bones or all the aeric part of the body, like the lungs and the skin, combining both. And this is the kind of images you can get. So that can seem quite simple, but the problem was from the CT scan, the amount of data you get is really huge. And a few years ago, the computer weren't able to compute all this data. So the first thing was to answer the question how to deal with all this amount of data, how to be able to transfer quickly the data to make all the users be able to connect on a website and work on it in real time, and how to share the data. So the solution, I'm going to try to be quick. The solution was to build GPU servers. So we use the graphic processor unit of the computer, and so we use the power of this graphic processor to make the computer able to compute a huge amount of data. But the other thing was that we wanted also to be able to have a solution that can have a lot of people connected on it at the same time from all around the world. So we created a cloud GPU server, and so with this structure, we managed to have a real-time web-based viewer. And so now the only thing you need to have an access to the internet using a Mac or PC or even an iPhone or like iPad and suit an Android. And you choose any browser you want, and you just need to connect on the internet and you have access to all your data. So this is an example of the software. The studies we did with an instrument, the measures. Here again, some other measures. And so once you work on an object, you'll have all your work on your page, and you can share it with everyone you want, like with other museum, with colleagues. And so I show you like a live demo. It's not really a live demo because we don't have access to the internet there, but so I recorded my screen yesterday, and so this is it. So the first thing you have to do is connect on the internet and go on the website www.visual3d.com. And then you log in. But if you don't have an account, you can just register, create your account, and then you can log in. So here on the front page, you can see all the work you've done recently. So I work on my head, but I can also have access to the work I did like a few months ago. And so you have all the subjects you scan, you got the list, and you can click on one and have access to the viewer from there, or you can click on one of your bookmarks, and the software will upload all your work. So the colors, position, and everything. So this is real time. It might seem quite slow, but it's really impressive for the amount of data. So here, so you have all the images, the 2D one, X, Y, and Z. and the 3D. You can work on the 2D if you want. Basically, it's more for radiologists. They prefer to work on 2D. Or you can work with the 3D one. You can turn around. And if you don't want all this pixel stuff, you can switch to high quality, but it becomes slower. You can zoom in, zoom out. You can add labels. And so you have some preset filters. So you can click on one and you add the skins. And if you prefer, you can also choose to manually set all the colors and transparency stuff. So you can change the color. This is just an example. It's kind of awful, so I go back to the real one. You also have a tool to make slices of the subject. You can cut it from the front or from the back. And finally, the measures tool, the one we use with Alain. And so once you're happy with your measure, you can save a bookmark. And so you'll be able to come back to this bookmark, share it, and be able to get the pictures. This is another bookmark I did before. And so if you go back to your first page and you refresh, you have access to your new bookmark. You can see the image here, and you can share it to your contact. It's like a Facebook for 3D. Yeah, so you have contact to send a request that I accept, and then you can share everything. So you can make also videos, we'll see later, and you can share the videos, put it on YouTube as well. And if you want to upload DICOM, for example, if you have your proper DICOM, if you just have a scanner, you can select your DICOM and upload them directly, and you'll have all your data there. And you can load new scan from there as well. So we're going to try another head. But once you load the data directly, not from the bookmark, you have to do everything, to put the color, to cut the scan table. And so this head is the one Alain Froment mentioned earlier. I mean the one without the skull behind the skin. It was just plasters, and the skin was fixed with the metal pieces we can see there. And finally, I will just show you how to make a movie. You just need to place a key and then move the object, move the time bar, place another key. And then you have your movie. You just need to save it. And so I did save it, and here's the movie. So yeah, that's it. And so I did save it, and here's the movie. So yeah, that's it.